Welcome! First of all, this video has subtitles, so if you don't understand me, just activate those. Also, this video is not an entry-level video, which means that you will need some knowledge about how Unity works in general, about the shaders within Unity, and also some C# programming knowledge. In this video I will show you how to manipulate particles using the Custom Vertex Stream of the particle system. I am going to use an implosion effect as an example because it is not an effect that is easy to do without using Custom Vertex Streams. To begin, we need a particle system, effects, particle system. We also need a shader, and both on lit and PBR will do. So on lit, implosion. We also need material, implosion material, and the shader goes into the material and the material into the particle system. We're going to activate the Custom Vertex Streams. We don't need the normal, but you can include it if you want to do something with it within the shader. But for this tutorial we are not going to use it, so remove that. Now we are going to edit the shader. We need a vertex color node. This node is where this color comes in. The color of the particle system, here, the second one, is going to modify the vertex color within the shader. We probably want to have a texture here, so just texture. Let's sample that texture. And let's multiply the color. Okay. This can go here. And let's split this to get the alpha. There it goes. It's not going to be transparent because we still have to modify a couple of things, but we can see that if we modify this color, it's going to modify the color of the particles. Let's assign a texture too. Let's see, this normal particle will do. And there it goes. Let's change the opacity options. Let's make it transparent and blend additively. Save. And well, we have the standard additive particles. You can see that the object space that is being set by the particle system through here. But we can put it in a node, create node, position. You will see that it is the same information. But now we're going to add more information here. The center, that's the center of the particle, and also the h%. This information will be coded through the texture coordinates of the this is the UV. This is the UV0 and this is the UV1. The UV0 we are currently just using two coordinates, the x and the y, to encode the UVs of the particles itself, of the texture within each particle. But C and W is not being used, so we can we are going to use that Z and W to encode the information of where the center of the particle is. Since that is not enough, it's going to extend into the UV1 in the x coordinate. So let's receive that information. Let's create a node UV0. Let's split it. The split node is representing here a color with RGB and alpha, but this could be interpreted also as X, Y, Z, and W. The X and Y, as I said before, currently used by the texture, so we are not going to use that, but we are going to use the other two. Let's put them all together again. Let's combine them. This will be our X, that will be our E. Oh, better than combine. We're going to create a vector 3. That's better. Here it goes now. Another UV. This is going to be the UV1. Going to split it too. And the first coordinate is going to be the Z of the position. So center position. And the Y coordinate, that's the G here, this is going to be the h% of the particle. So create node vector 1. This is not needed because since this is just one coordinate, we could directly link into whatever, but just for clarity's sake, let's make a group and put a name on it. Now, to bring the particles to the center, what we can do is do a lerp. Okay. Between this position and the point where we want the particles to go. For now, let's just put 0, 0, 0 here, and let's see if the particles go to 0, 0, 0. Okay, we see that the particles are coming back to the 0, 0 position, which is also the position, well, it's almost the position where the particle system is. But we can see a problem here. They are getting smaller and smaller as they travel. That's because all the vertex of the particle getting together. So we don't want that. We want to save the distance from the center to the position, from the center of each particle to the position of each vertex. And that's why we wanted the center position of each particle. So what we are going to do is subtract to the position center. We're going to lerp this, and then we're going to add it again. And okay, it's the center we have to learn. So there it is. Let's change some settings on the particle system to make it look more like an explosion. Speed 0, lifetime 2. Not over time, but as a burst, and shape it like a sphere. Let's make this sphere bigger. And now this looks more like implosion. And the problem now is this. Is that the center is fixed, the point where the particles converge. So how can we set it to the location that we want? One thing we could do is create a new input and just change it on the shader, or change it at runtime from a script. But this will only work if we want all the particles to converge on the same spot. We can actually make each particle go to a different location, but for that we're going to need to use some custom data. And by the way, doing this, trying to take the object position here does not work. For some reason, the position we get from there is 0, 0, 0 again. So let's remove this. And what we are actually going to do is use a custom vertex stream to pass that information. So we have custom 1 x, y, z. It's a position in space, so we can use that. And we see that we're using the text code 1, ZW, ZW and X. So let's add that. Let's add that here. UV. UV2 and another vector 3, and this will take this, this, and this, and I'm going to group this. Oh, not that. I'm going to group this and give it a name, and the name will be target position. And with this we can even give each particle a different target position, so each particle goes to a different location. Let's link this here. And the problem now is, let's put some order in this. Okay. And the problem now is how to put the target position in here, how to pass this information to the shader. And for that we're going to use a script, and the script will use the particle system to inject that information into the shader. So everything here is running on the shader, it's running on the GPU and not the CPU, so it's actually really performant. Let's see how to do that. First we're going to create a new script. Let's call it Implosion Manager. Let's hit this. Here we will need a reference to the particle system. So serialize field, private particle system. Let's just call it particle system. Now let's create a function called manage particles. Alright, and here we will need a list of vector 4 to host the custom data. So let's initiate this. We use the particle system to fill the custom data, get custom particle data, and custom data, and the data we want is the index 1, the custom 1 index. Just to make it clear, here, this is the custom 1. When we add a new custom property here, a new custom vertex stream. We can choose between custom 1 and custom 2, and in this case we are using the number 1. And now we're going to store a position, actually a vector forward. It's going to be a position. It's going to be a vector 4 because that's what set custom particle data requires. But here we are only going to use three positions of that vector 4, and we're going to use just the transform dot position. The cast is automatic. We could do this, but it's not required because this position is vector 3. So now we put this information into each one of the custom data vector 4s. So for int 0 to 1 while is less than custom data.count plus custom data position e equals center position. And now we return this to the particle system. Set custom data, and you use data and custom 1. Okay, so for this to work, we cannot use the default emitter of the particle system. We have to make the particle emit via code. To do this, in this case, I'm going to use the onEnable, function of the mono behavior. So void on onEnable, and well, before that, let's set the particle system. If particle system equals null, then get component, blah 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 blah. There. And here we stop the particle system in case it is running. Including the children, and not only stop but stop and clear. The next thing we do is particle system dot emit. This emit is deprecated, I think, but still it's the only way this will work. Let's set it to just 20 particles. Yeah, that's deprecated in Spanish. So if anybody knows any better way to implement this and make it still work, let me know. Yeah, just write it in the comments. But At the moment, that's the only way I know that this will actually do what it's supposed to do. So let's save this and let's see if it works. It will not work in the preview. All this will make put a lot of limitations on how we use the particle system, and one of those is that it's not going to work in the preview. Maybe using some editor functionality in the script will make it work, but that's out of the scope of this video. So let's assign this. I'm going to disable the emission. Don't need this. And let's see, is this ready to? I think so. Let's hit play and see if it works. And it does. It goes to the center of the game object, as you can see. Still, if the game object moves, still if the game object moves, let's see if I can make it move. Is it running? Yeah. The position will keep the same because we have set that position, that target position at the start. But what we can do to fix that is what I said before: create a new value here with the object position and update it in the script as a property of the shader. And that's all. I hope you have fun trying new things with the Custom Vertex Streams. There's a lot of things that you can do. And well, see you around. Goodbye.